Good day, good people. Welcome to JJ Tech Tutoring. Today I will be taking you guys through application of ODE, right? So this is just the simplest question in the heating and cooling context. So be reminded that when we're dealing with heating and cooling, we always use Newton's law of heating or cooling models to rise or drop in a temperature, right? And then we do that over time, right? So I'll just write the law that we are going to use, plus or minus, because still we're still saying it is cooling and heating, right? So this is the room temperature. You can just decide to write TA, which is it's an ambient temperature. You can just refer it as a room temperature for science, right? So I just have to discuss this, the role of each and every variable here, or the important variables, right? So K is the rising or dropping factor, right? K is constant of professionality, and Tm, as I've said, is an ambient temperature, the temperature of the medium around the object, right? So here the temperature of the medium, or the medium, it was refrigerator. I'm still going to read the question for you, right? So note that when K is greater than 0, the temperature increases, right? So that means it will increase, it will heat or warming the surface. And then if K is less than 0, is when the temperature decreases, so which is cooling, right? So this is some basic things that you have to know. When K is less than 0, it is cooling. When K is greater than 0, it is heating. So those are the things that you must know. That's when you know when to include plus or to include minus, right? So we can just quickly read the question, then we know if it's cooling or heating. But then now, to be at the safe side, you can just leave the signs and just do your separable integration, right? So now, a chicken has been kept in a refrigerator at a temperature of 40 degrees Fahrenheit and then placed in an oven that was preheated to the temperature of 325 Fahrenheit. So that was preheated. That means this has been the medium, the temperature of the medium is that one of 325 degree Fahrenheit, because when we put the chicken there, already it was preheated. So if they're saying it was preheated, that means it's the room temperature. The room of the medium was already in 325 degree Fahrenheit. Then they're saying after 20 minutes, right? After 20 minutes in the oven, the temperature of the chicken is 60 degree Fahrenheit, right? After 20 minutes. So we can just say T is equals to 40 degrees C F. So what we can talk about this, you can just say T0 is equals to 40 degree F at the initial point. At the initial point, our temperature is 40 degree, right? So after 20 minutes, our temperature is, right? After 20 minutes, because after 20 minutes in the oven, the temperature of the chicken is 60 degree Fahrenheit, right? Now, how long must the chicken remain in the oven to reach the temperature of 185 degree, right? So we need to find the time, or how long is the chicken needs to remain in the oven. So we need this time, right? But then all in all, we need to maneuver around with the equation. We need to try by all means to just integrate, do separable, and put it in a standard form. This is what we have to do. So you can just write it as it is heating, right? It is heating because it's talking about in the oven, right? So we have to write it in a positive without negative or plus or minus, right? So now the T over is equals to KT. So this is our ambient temperature. This is our ambient temperature, right? So now we have to do separable integration. We have to do separable integration. So dt minus 325 is equals to, that is k dt, right? So direct integration. So it is just nt minus 325 is equals to k of t, right? Plus c. K of t plus c. Right. So we then have to put it in a proper form. We can just do in an exponential, from logarithm to exponential. So right, so now the rules of exponent or multiplication, you can just say, right, so that means this is our constant, right? So we can just say this is equals to maybe t initial, right? So you just have to say 325 is equals to t initial e, right? You can name it whatever that you want, right? So we need to look for this, right? And the only way that we can find this is at our convenient, at the beginning here, right, where time is 0, where time is 0. So here we need to say t minus 325 is equals to time initial e to the power kt, right? So when t is 0, our temperature is 40 degree Fahrenheit, right? So we just have to say 40 minus 325 is equals to t, what we are looking for, e to the power k, then 0 for the time, right? Then 40 minus 325 is equals to ti. So here it will be 0. Then when it's 0, it will be 1, right? So let's see. 40 minus 325. 40 minus 325. That means it will be negative 285. Negative 285. So that means our complete equation is, it can be t is equals to, take this that side, negative 285 e kt plus 325, right? So we took this that side, and then from there we substitute this because we just found it. So that is why now our equation is like this, right? Right. So we need to come now and find our k, constant k. And usually they might give it this one. They can give you in terms of percentage. They can say the 15%, or they can say 20%. You just have to take it as it is. Then it will be your rising or drop factor. So it can come in percentage. If you see the percentage in your statement here, in your statement up here, just know that it's your k, right? But now that here it is not given, we have to look for it. We have to look for it. So there is a point whereby after 20 minutes, the temperature is 60 degree Fahrenheit, right? After 20 minutes, it's 60 degree Fahrenheit. So now we have to say 60 degree is equals to negative 285 e to the power what? To the power what? K multiplied by 20 plus 325, right? So 60 minus 325 is equals to negative 285 e to the power 20k, right? 20k. So 60 minus 325, that is 265, minus 265, right? That is minus 265. So it's equals to minus 285. Then e to the power 20k, right? So we're going to come here and divide both sides by 285, 285, right? Now, negative 265 divided by negative 285. It is giving us positive 53 divided by 57 is equals to the power 20k, right? Right. It's very easy. It's very easy, guys. Let us now look for our k. Now, we have to apply natural log. Natural log, right? Because we are solving for k. Now, natural log 53 over 57 is equals to 20k. Natural log, right? And you know very well, by this time you know that this part is 1, right? So we're going to just have natural log 53 over is equals to 20k. It's equals to 20k. Now, you just have to now divide, multiply both sides by 1 over 20, right? Now, your k is 1, 20, natural log 53 over 57, right? So this is your k, right? So the equation that will be in your standard form, if you can be asked that, okay, write your equation in a standard form, that means you will be ready to find your time, right? So you just have to say, come back here. and say, okay, fine, T is equals to negative 285 e to the power what? 1 over 20. Why am I not using my calculator here and always carrying this thing? It is because I want to get an accurate answer. I want an accurate answer. That is why I don't want to mix up this. I don't want to mix up this. You must make sure you don't mess up this, right? Write it properly. Don't use your calculator because you will have to round off, because it will give you numbers that are recurring. Then they will be just repeating themselves, right? Now, this is your standard form. Now here you can find your T, right? Because they told you that, okay, find the T when what? When the degree, the temperature is at 85 degree Fahrenheit, right? Now, you just have to come now and take this temperature, put it here on T, right? Then look for this T, easy as that. Now, let us now right? Then plus 325. Now T is equals to negative, no, here we just have to put 185 is equals to negative 285 325, right? Then take this that side, 185 minus 325 is equals to negative 285, then e to the power 1 over 20 ln 53 over 57, right? So 185 minus 325 is equals to negative 140, right? Then is equals to negative 285 e to the power 1 over 20 ln 53 over 57, right? Then divide both sides by negative 285, so it will be 1 over 20 ln of 53 over 57 is equals to T, 57T, T is equals to what? Then what is this? Negative 140 over minus 285, that is 28 over 57. 28 over 57. Now, we need to put natural log again. Natural log again. Right. So, obviously, this will come this side, 20 ln 53 over 57 T. Then, we'll be left with this. Then here is ln of 28 over 57. Right. So, this side will go away because it's 1. Then, we'll be left with 1 over 20 ln 53 over 57. Then, T is equals to ln 28 over 27. Right. Then you just have to have T here. Then divide that both sides by the whole of this information. It will be ln 28 over 27. Divide by 1 over 20 ln 53 over 57. Right. Then your T is, let us calculate now. Over, so yeah, you just have to say 28 over 57. Yeah, my bad here. It's supposed to be 57 here. Just here, 28 over 57. Yeah. Very good. So you just have to say 28 over 57. So then your answer is 195. 195 maybe 4 minutes. Right? 195 minutes. So that's what you should do. Right? So maybe quickly recap on how we went about this, right? So the question was, a chicken has been kept in the refrigerator at the temperature of 40 degree Fahrenheit and then placed in an oven that was preheated. So that means here the initial time is 0, then 40 degree Fahrenheit. Now it is placed in the oven that was preheated, right? This is the preheating, which is the ambient temperature. Then after 20 minutes, the temperature of the chicken is 60 degree Fahrenheit, right? How long must the chicken remain in the oven to reach a temperature of 185 degree Fahrenheit? So now we are asking the time, right? We're asking the time. Now, this is the Newton law of cooling and heating, right? So we just have to substitute by the ambient temperature and then do direct integration, do separable integration, and then you reach it, right? Then from here, you have to look for this constant, right? You have to look for this constant. After looking for this constant, like we did here, you have to take this constant and substitute it back here where it needs to be. So here is my substitution, right? Then from there, T20 is equals to 60 degree Fahrenheit. Then we need to look for K, right? Then this is our K. This is our K, right? After having our K, we have to take it back to the equation, right? After having the equation, now we have to look for T. So this way, when we're looking for T, and when we're looking for T, it is easy now because we just have to say our T, this one is 185, right? Then from there, we put 185 here. When we're done putting 185 here, then we look for T. So everyone can just solve that, right? Then we found that our time is 195.4 minutes. So all in all, don't forget to subscribe. This question is very important. So if you manage to get this kind of a question and understand heating and cooling, why not subscribe?